And welcome back. Example 4. We're still solving equations, having fun stuff here. This equation is sine 2 theta equals half. And if you also notice, we have restrictions on our answer. The domain is restricted, basically. Theta must be between 0 and 2 pi, or theta must be between 0 and 360 degrees, which also means one full rotation. The angle here is doubled. Please notice the angle here is doubled. So if we claim that the angle would be 15 degrees, we're basically saying that sine of twice of theta, which makes the angle 30 degrees, must equal half. So this statement must be true for that particular theta value. In this case, it is true, so I do know that's one of the answers. But it's important we understand the difference between twice of the angle versus if the 2 was on the outside, 2 sine theta. This one's referring to sine theta. So if theta was 15, then I'm saying sine of 15 degrees, whatever the value is here, that value needs to be doubled. So please understand the difference between when to square double the angle versus double the value. All right, let's get started. Now, first thing I'm going to do is on the side, I'm going to say that x is equal to 2 theta. So I'm going to make it look like partial algebra, and I'm looking at x equals half. For what angle does sine equal half? That's a positive value of sine, which means we are looking at quadrant 1 or 2. So there's a theta value here, and also there's a theta value. This theta would be the reference angle, by the way. That's not going to be the final answer. But definitely there's an angle here where sine is still half. Opposite over hypotenuse, which means the third side is root 3, and on this side it'll be negative root 3. Our job is to find all those possible angles. That's 1, which means this angle must be the 30-degree angle, which means x is equal to 30 degrees, which is pi over 6 in radians. Pi over 6, which means we're going up in a sixth, which means this is also pi over 6, which means the actual angle, which is this one, would be 5 pi over 6, because we are a sixth away from pi, which makes it 5 pi over 6. So the other possible answer is x is equal to 5 pi over 6. And no answers are going to come from here or here because both these quadrants, sine value is negative. Now carefully replace x back with 2 theta. Replace x with 2 theta. Our job is not to find 2 theta. Our job is to find the value of theta. Also notice we're restricted here, but the next possible answer, this is pi over 6, the next possible answer is going to come from the second rotation. Like I said in the previous example, sine and cosine are periodic every 2 pi, which means if I add 2 pi and then times it by k, add 2 pi times it by k, that has incorporated a lot of answers for us. Let's go ahead and start finding them, while keeping in mind that we cannot get above the 2 pi. Okay, we're going to use our k values 0, 1, 2, so on and so forth. However, 2 pi k. However, we're not trying to find 2 theta, we're trying to find theta, so we'll have to divide everything by 2 so that we get the value of theta. Pi 6 divided by 2 is basically pi over 12 plus pi times k, because the 2's are going to cancel. The pi over 6 divided by 2 is basically keep, change, flip. That'll make it half, which equals to pi over 12. So that's that. And then on the other column, 2 theta can also be equal to 5 pi over 6 plus 2 pi k. So theta would equal 5 pi. We're dividing everything by 2 plus pi k. And now let's start substituting. Pi 12 plus pi times I'm going to put our 1, 2's, and 3's. I'm going to do 3's so far, and let's see how far that gets us, because we want to make sure we stay within range. So 0 for k value, 1 for k value, 2 for k value. Let's see what that equals. This would give me pi over 12 for theta value. Okay, adding pi is basically adding 12, 12, which makes it 13 pi over 12. And honestly, here I figured out the pattern. We're adding 12 pi to the numerator. So I've already figured out the pattern. 25 pi over 12. Let's analyze our answers. We want to make sure we don't jump over 2 pi. So this is well within 2 pi. 13 twelfths is just a tad bit over 1. That's within 2 pi. 25 over 12. Oh, wait a second. We have bypassed 2 pi. This range is slightly, this last solution is slightly outside of our specified domain. So I'm going to cross this out. This last solution is outside the specified domain in the question, which was theta must be between 0 and 2 pi. So basically I got two answers from that side. Let's go ahead and work on the next one. I have a feeling we wouldn't have to go past 2 again. So let's see. 0 here, 1 here, 2 here. That brings us back to the first solution. Being able to add that, I'm multiplying by 12 and 12 because I'm basically multiplying by 1. That makes it 17 pi over 12. And as you can see, we're simply adding 12 pi to the numerator, so I really don't have to do a lot of math for the third one. I'm just going to add 12 pi. 29 pi over 12. Let's analyze these answers. 5 twelfths is clearly less than 2. 17 twelfths is less than 2. 29 over 12 we have gone past. So this part applies to both of these last solutions, which means we have found exactly 4 answers. So theta, that's the first answer. And you need to go in increasing order. 13 pi, 12, and 17 pi over 12. And those are exactly 4 answers that are part of the solution set. We did not get infinite number of answers just because our question had restricted domain. So I hope that helps. See you in the next video.